The science behind heat shrink. Heat shrink tubing is a staple in the world of electrical insulation and wire protection. But have you ever wondered how it actually works? The magic lies in a fascinating combination of polymer science and thermal dynamics. In this article, we'll break down the science behind heat shrink tubing, how it responds to heat, and why it's such a reliable material in countless industries. What is heat shrink tubing? Heat shrink tubing is a thermoplastic tube that contracts in diameter when heated, forming a tight, protective seal around wires, cables, connectors, and splices. It is commonly used for insulation, strain relief, moisture protection, and even color coding. The material behind the magic. Cross-linked polymers. At the heart of heat shrink technology is the polymer material, usually polyolefin, although other materials like PVC, PTFE, and fluoropolymers are also used for specific applications. What makes polyolefin ideal is its ability to be cross-linked, a process where polymer chains are chemically or physically bonded to form a stable, three-dimensional structure. This gives the tubing memory. Once it's expanded, it remembers its original size and shape, and will return to it when reheated. How heat shrink works. Step-by-step science. Extrusion and expansion. The tubing starts out in its final shrunk size and shape. It's heated and mechanically expanded while being held in the expanded state until cooled. This locks in the stretched shape. Cross-linking. During or after the expansion, cross-linking occurs. Heat activation. When end users apply heat, usually with a heat gun or oven, the tubing returns to its original diameter, wrapping tightly around the object beneath. Why heat shrink is so effective. The combination of heat responsiveness and structural memory makes heat shrink tubing incredibly useful. Once it conforms to a surface, it creates a durable, secure, and insulating barrier that is resistant to abrasion, chemicals, UV light, moisture. Moreover, dual-wall tubing contains an inner adhesive lining that melts during the heating process, bonding the tube to the surface and providing watertight sealing. Applications in real life. Electrical engineering. Insulating splices, joints, and terminals. Automotive aerospace. Protecting wires from vibration and high temperatures. Marine. Waterproofing cable connections in corrosive environments. DIY electronics. Managing wires in custom PC builds and hobbyist projects. The next time you apply heat shrink tubing, you're not just using a plastic sleeve, you're engaging with a clever application of polymer chemistry and thermal engineering. Its ability to react to heat, maintain structural integrity, and protect components makes it a go-to solution for professionals and common handymen alike.